Thanks, Grace, for the introduction. Hello, everybody. Welcome to this talk. The work I'm presenting today is the result of a joint research project which I'm doing together with my colleagues. On the one hand, Rainer Weinreich from the JKU, and together with Heinz Huber from RSG, who is the industry partner of this project. So, at the beginning of this talk, let me tell you a little bit more about our industry partner, which sets the context for this work. RSG is developing solutions for the financial domain in Austria. It's a company with about 800 employees, which work at 7 different development sites located in Austria and other sites in Europe. RSG is constantly concerned with evolving their systems in response to new requirements. On the one hand, technological requirements, and then on the other hand, new business requirements. So just to give you a few examples, what keeps RSG busy these days. On the one hand, RSG is in the process of migrating its service-oriented architecture towards microservices. This includes making many technological changes. For instance, RSG has replaced its SOAP-based APIs with REST APIs, and RSG has this year released a completely new online banking solution based on Angular. Hand in hand with the introduction of microservices goes also efforts in increasing the release frequency of the software products, which also requires new strategies for release and testing. And finally, RSG is also forced to open its banking solution systems to other companies by opening and providing dedicated APIs. Together with RSG, we have a long-running research cooperation which started in 2011, and the main theme and topic of this cooperation is the development of concepts and tools for architecture information extraction. One of the basic principles at RSG is the source is the only truth. So RSG depends on a lot of architectural information, and this information they need, they have to trust in this information, and they say that many documentation which has been produced in the past is not kept up to date and maintained, and so it's often difficult relying on this documentation. At the beginning of our work, we were focusing on developing IDE-based tools supporting solution architects and supporting the analysis of single SOA subsystems. In recent years, we were confronted with new and significantly extended requirements and use cases, which required us that we develop a completely new platform for providing architectural information. Here I brought some of the aims and requirements of RSG, which they have for our platform. First of all, RSG wants valid, this means complete and up-to-date architectural information. This information shall be provided to different kinds of stakeholders, but different stakeholders require slightly different kinds of information. Further, provided information should be standardized. This means that all developers in the company speak the same language, use the same concepts and terms, and also architectural information is provided in a unified and standardized way. Since systems developed by RSG is large scale, a solution must also be able to support a large code base. And RSG not only wants to analyze its current state of the system, but it also wants to analyze the evolution of its systems over time. And last not least, RSG wants a fully automated solution, because otherwise it's rather unlikely that a developed approach will actually be used in the company. So what we did together with RSG is, the first thing is, we have developed a conceptual model for describing their systems at the higher level of abstraction. We call this model the RSG component model, which you can see on this slide. This model is actually part of RSG's reference architecture, and as you see it here, these elements are in essence a unified set of concepts used by different kinds of stakeholders, and not all stakeholders are interested in all of these elements. For example, solution architects, which are concerned with the design of deployables, a deployable in the context of RSG is a Docker image which is to be intended to be operated at RSG's private cloud environment. A deployable contains one or more software module, where a software module actually provides one or more services. Contrary, a designer is concerned with the internal design of a software module by defining the internals of service components which provide services. This means a designer is concerned with the design of database and host components, as well as the integration of services provided by other software modules by means of service proxies. A release manager, for example, is concerned with the definition of releases. This means he selects a number of deployables and software modules which are to be scheduled together for a release. And he is concerned with defining consistent and complete releases. This means that the release contains all dependent deployables, and that all these deployables are also contained in the release in the right version, that a release is compatible and complete. Yeah. And finally, software testers. Software testers are concerned with testing for a particular release. This means they have to test the software modules which are part of the release and the services which are intended for a release. This means they have to test use service endpoints for testing the released services, and they are also interested or concerned with testing so-called TRACOs, which are transaction codes representing operations provided by a mainframe system. The model, as you can see it here, can completely be extracted from the system implementation. Therefore, RSG has extended its technology stack, and by enriching the system implementation with corresponding metadata, that this model can automatically be extracted. And for extracting this model, we have developed a dedicated platform which extends the project infrastructure operated by RSG. So extraction of architectural information in our case is a three-step process. In the first step, we are bringing the system implementation into an analyzable form. We are doing this by copying the system implementation and storing it in a database and performing source code analysis by means of database queries. In our case, we're using the Neo4j graph database for doing this. The information contained in the database is updated as part of cyclic build processes. RSG updates this information on a daily basis as part of nightly quality assurance builds. In the database, we are storing the system implementation for every released software version, and along with the version of the currently development iteration, and as part of the nightly builds, we are completely replacing the source code of the current development iteration. So in the database, we have the current version of the system implementation along with all released versions. In the second step, we are using different kinds of code analysis which we provide to a set of services which use this low-level code analysis for different tasks. For example, we have a component model service which extracts the component model which I've shown you on the previous slide. We have a dedicated rule analysis service which analyzes the system implementation for inconsistencies or missing metadata, which causes the architecture extraction to be incomplete. And finally, we have a release analysis service which analyzes the integrity and completeness of releases. In the third step, these services provide information to a set of different tools which are used by RSG for system development. For example, the rule analysis service provides detected issue to a quality dashboard. In the case of RSG, this is a SonarQube dashboard. The release analysis service is used by a dedicated release planning tool. The contents of the RSG component model are displayed in an enterprise architecture management platform tool. And in addition, we are also working on some research prototypes. For example, we have we are developing one prototype for automatically generating viewpoint-based architecture documentation. And we have a dedicated tool called the Test View, where we support software testers in their work. Just to give you a little bit a better impression on how we provide architecture information in other tools. Here you see a tool called XL Release. It's a commercial tool used by RSG for the definition of release pipelines. And in this tool, we have extended this tool by providing information on dependencies between deployables. For example, when a release manager defines a release and selects a deployable, we should provide a list of dependent services, including the required versions. And in the second step, we are verifying releases so that only if a release has been verified to be complete, any manual testing activities in the release process may start. This is a screenshot of the so-called Enterprise Architecture Management Platform. It's a system developed by RSG, which they use for SOA governance activity. In this tool, the developers and solution architects can look up information on any developed software artifact developed by RSG, and they can browse additional information like the responsible people, release history, provided and required services, and other information. A test view is a research prototype where we support testers in software evolution analysis. At this screenshot, for example, we are comparing two releases of a software system, and we want to indicate or show the tester which changes in service usage between two versions have occurred. In this case, any red line represents a service call which has been removed. A green line represents a service call which has been introduced in the current version, and yellow lines indicate services where the usage frequency has been changed, giving a tester an impact or help them on which kinds of testing they shall concentrate on. For example, if the usage has been increased, they shall increase or focus in particular on load testing. In order to validate our developed platform, we have conducted a case study, and as part of this case study, we have answered two research questions. First question, does the platform scale to real-world industrial use cases? And the second research question, is the extracted architecture information trustworthy? Both of these research questions are of fundamental importance for RSG. We have, as unit of analysis, we have analyzed the complete online banking solution of RSG, which was released earlier this year. And for data collection, we have used runtime monitoring and log file analysis for answering the research question 1. And we have, for answering research question 2, we have had a look at the results of the rule analysis service. I should also mention that we have conducted this case study directly at the infrastructure at RSG in the company to really obtain results under real industrial conditions. So, what were the results of our case study? Regarding the first research question, does the platform scale to a real-world industrial settings? So we have analyzed really a lot of code. In our graph database, we have stored over 44 million lines of code, which in sum accounted for more than 8,000 Maven modules. From these 8,000 Maven modules, over 3,500 modules were source modules developed by RSG. The remaining modules were third-party libraries. The online banking solution at RSG consists of 89 deployables and almost 300 different software modules. Regarding the performance or scalability, we have compared the duration of a quality assurance build without having our platform activated, which was the baseline, to build durations having our platform enabled. And as you can see in this diagram, the average duration of an entire quality assurance built without our platform lasted for 4.6 hours. And if we have our platform enabled, the build duration is significantly extended to 7.4 hours for the component for the code parsing step, and then we require an additional step which lasts for 1.2 hours for doing the component parsing and extracting the component model. So if we break this down at a deployable and software module level, you see that the code parsing duration goes up from 2.9 minutes to 4.8 minutes, and the component parsing step lasts for about 15 seconds per software module. So although this is a significant extension of the build duration, we were still able to conduct this extraction process on a daily basis as part of nightly builds. And actually what we also can see is that most of the time, or the overhead, is actually simply required for storing the source code in the graph database. This is the step which requires most of the time. The component parsing and the extraction of the component model, which lasts about 15 seconds per module, is rather fast. So these were the results regarding the scalability. And regarding the second research question, is the extracted architecture information trustworthy? We had a look at which kinds of problems we could find in the software modules, and here it turned out that from the almost 300 modules, about more than 180, so about 2/3 of the modules contained no issues, while in about 1/3 of the modules we could detect some issues which caused the extraction to be incomplete. If we had, then we had a closer look on how many problems per module were found, and there it turned out that in most of the modules we only had between 1 or 2 problems. We only had 5 modules where we had between 5 and 10 problems, and 2 modules with more than 10 problems. So having a more detailed look at these problems, it turned out, or RSG could tell us, that for the most of the modules, the detected issues can be resolved rather fast. And discussing the results of these issues is, of course, the current state of the quality of the extracted information is not the standard that RSG wants or requires, but they are optimistic that they can improve the quality of the extracted information in the future with reasonable efforts. In addition, RSG also decided to introduce a dedicated quality control step as part of the service development lifecycle, where solution architects have to verify the extracted information to be complete. Yeah, that was all what I wanted to tell you. Just to sum up the main points of what I have presented today, we, together with RSG, we have developed a conceptual model for describing service-based software systems. This model can automatically be extracted from the system implementation in order to provide valid and up-to-date architecture information. Therefore, we have developed a dedicated platform which extends the infrastructure at RSG. This architecture information is provided to different sets of tools where this information is integrated, and we conducted a case study in which we found out that the platform is able to provide architecture information on a daily basis, and that also the quality of this extracted information can be assessed and hopefully be improved, that this information is in the future trustworthy. So much from me. Thank you very much for your attention.